Okay, in this section 9-3, we're looking at parabolas. So that's the next type of conic section that we are going to discuss. And so we look at the formal definition first. So the definition of a parabola is the set of all points in a plane that are equal distance from a fixed line, which is the directrix, and a fixed point, the focus, that's not on the line. Okay, so the midpoint between the focus and the directrix is the vertex, and the line passing through the focus and the vertex is the axis of the parabola. So what we've got here is, okay, we've got a point that's kind of in the interior, so to speak, of the parabola, called the focus, and then a line underneath it that's called the directrix. Okay, so the set of all the points that are the same distance away from the focus and the directrix, those are all the points that make up the parabola. So in other words, this distance will be the same as this distance. So the focus, the vertex has got to be halfway between the focus and the directrix on the axis line, right? So if I come out, let's see, a distance here, right? Okay, the place where that's the same distance away from the directrix, of course, it's got to be 90 degrees, the perpendicular distance. That is another point on here. And if I come out this way, okay, once I get to the spot where that is the same distance away from the line, that's another point on the parabola. Okay, that's another point on the parabola. All right, and then just kind of all the way down the line until I get as many points as I want on that thing. Okay. Let's see, did we discuss pretty much everything? I think we did. Just notice all the parts. The axis, the focus, vertex, directrix. Okay? Axis and directrix will always be perpendicular to each other. All right? Let's see. Now, the standard form for the equation of a parabola is this, to where h and k, that will be your vertex, right? And the value of p, right, is going to be a constant that can be obtained from these equations. But now, here's one thing to think about. If the x expression is the one that's squared, then you have a vertical axis. So in other words, the parabola opens up or down. Okay. If the y expression is the one that's squared, then you've got a horizontal axis, right, and then your parabola opens either left or right. Okay. So that's what we're kind of looking at here. It all depends on which one of the variables is squared, which one of the expressions is squared. Okay? And the line for the directrix can be written as y equals k minus p for a vertical parabola, and a horizontal parabola can be written as x equals h minus p. All right? And with this value p, the focus lies on the axis p units from the vertex. P units from the vertex. All right, so that distance right there is P. All right, that distance right there is P. Okay. Let's see. And of course, if you've got a vertex at the origin, then the parentheses are gone. All right, and that's the form that the parabola takes on. Okay, so now this is a different form than you are used to seeing for a parabola in Algebra 1. Like in Algebra 1, or Algebra 2 for that matter, you typically see it as y equals x squared plus 2x minus 4 in that form, solved for y. Okay, so y equals form. All right? And I don't want to say general form because general form, this is not general form either. Remember, all the terms will be on one side and whatnot. Okay, so this is called the standard form, okay, of a parabola. All right? Let's see, and there's actually another form too that you can talk about as far as a parabola is concerned. But what are the types of problems we're going to be faced with? We can take a look at that after we look at another chart that I've given you. So this is basically another chart with the same information. Okay, and you've kind of noticed that as we've gone through this. You have two different charts. It's because they come from two different resources. And so some of you may like the way one is laid out over the other, but this is really the same information. And this one actually gives you some more information than the last one does. Okay, so again, if the x is squared, then it either opens up or down. So it gives you also a graphic and a visual, right? Let's see. And again, it gives you the vertex, how to get the focus, how to get the axis of symmetry, right? And then how to get the directrix as well. And then likewise, if the y coordinate is squared, then it opens left or right. And same idea. It tells you how to get the vertex, the focus, axis, the directrix, and all those things. Okay? By the way, you can tell by the value of p which directions the parabola opens. If p is greater than 0, then it opens up. And if p is less than 0, it opens down for a vertical parabola. And if p is greater than 0, opens right, less than 0, opens left for a horizontal parabola. So you can tell that information by looking at the value of p. All right? So what are we going to have to do? We're going to have to write the equation in standard form, identify the vertex, the focus, the axis of symmetry, and the directrix. So just like last time, we have 5 things that we have to identify. All right? So let's see. How are we going to do it? Well, the first thing we want to do is rearrange this to standard form. We want to put it in this form. Okay? So here are the steps. First thing that I would do here is just divide everything by 3, because all of these are divisible by 3. So if there's anything you can divide out, definitely do that first. Then we'll end up with y plus 21 equals negative 20x minus 6y minus 68. Okay? All right, so definitely divide everything out if you can. Do that first. The next thing that we can do here now is, and by the way, I left my squared off right here. So what we want to do on this next part of it is we want to group all of the y terms together and then all of the x terms together, right? And the reason why we want to do this is based on whichever one's squared, you want to group all of those together on the left-hand side, because that is the one that we're going to use completing the square to turn it into this form. So like on this one, my y variable is squared, and so we know that it opens horizontally, and this is the format that we're going to use. So I need all the y terms on the left-hand side and everything else on the other side so that I can complete the square in the next step. Thank you. Okay, thank you. All right, so from here, what we can do is we can go y squared, and then I'll move all of my y terms over to this side. So that'll be plus 6y, and we'll make that equal to negative 20x minus 68 minus 21. All right, so we're good there. And so now my next step here is to complete the square on this right-hand side. So again, I'll go y squared plus 6y. Cut that in half to 3, and then square it to 9. I need to add 9 now to both sides. So that'll be negative 20x. Oops. Need to make that 20. All right, so we'll make that 20x minus 68 minus 21, and then a minus 9. Go ahead and throw that on there. Let's see. What else we got? Okay, so on our next step, we're ready to go ahead and write this as y, and that would be plus 3 close squared equals, this is negative 20x, all right? And so with this now, we can, oh, I need to make that a plus 9 instead of a minus 9, so I noticed that kind of right away. All right, so if I put all these together, I can go 68 plus 21 and then minus 9. So that would leave me with minus 80 right here. All right. And so from here, what we can do, again, to get this into this form, if there's anything that can be factored out here, which it can, we're going to now turn this into y plus 3 squared equals, and what I can factor out here is a negative 20, really. So it'd be negative 20, open, x plus 4. Okay. So now at this point, I have it in this standard form. All right. So again, several steps. We had to rearrange it from the form that was in to get it into the standard form. Okay. And the reason why we wanted to rearrange that is because now that will help us to find all the remaining things that it asks us for. Like, for example, the vertex. Okay. So how do I find the vertex? The vertex is going to be, and once again, since the y's are squared, I know that I have a horizontal parabola. The vertex is h comma k. Well, I can get that from here. It's going to be negative 4 and negative 3, because remember, the h is with the x, the k is always with the y, and so that's going to be negative 4 comma negative 3. Remember, you got to change the signs from the way they are in the equation. Plus 4 changes to minus 4, plus 3 changes to minus 3. Remember, the h is always with the x, regardless of which side it's on, and the k is always with the y, regardless of which side that it's on. Okay, so keep that in mind. Let me see here. The focus is what we're looking for next. And so as we're looking for the focus is going to be h plus p comma k. So I need to find the value of p. Well, remember, whatever's outside of here is 4p. Okay? So what that means is 4p equals to negative 20, right? So that means p is equal to negative 5. And p is negative 5. Now I can go and find the focus because it's h plus p, right? So that is going to be negative 4 plus negative 5, which is negative 4 minus 5. So that's negative 9, comma, k, which is negative 3. So there is my focus. That's where my focus would be. The axis of symmetry. Okay. Axis of symmetry is going to be y equals k, so that's going to be y equals negative 3. And the last thing that we need is the directrix. Okay. Which in this case is going to be, it's x equals h minus p. H minus p, well, what's my h? My h is negative 4, right? And that's going to be h negative 4 minus negative 5. So that's negative 4 plus 5, which makes the directrix x equal to 1. So just keep everything straight when you're plugging in and calculating values, and you should be in good shape.